Good evening, everyone. I'm Eyad Abozalaf from Center for Heritage Preservation in Palestine. CCHP is an organization that works with cultural heritage and public awareness for heritage preservation in Palestine. My presentation today is about active and passive systems or energy efficiency systems compatible with traditional buildings in Palestine and the Mid area in general. Can I have Okay, so where I will start explaining a little bit about the architecture, the heritage architecture in Palestine, or it's nearly the same as in the Middle East. You can see here that this is the old city of Bethlehem. You can see here that there's different types of building. You can see like simple buildings, the yard, or what we call hosh, regular buildings, and you can see combined between each other, and you can see the palaces. Here you can see the Nativity Church and Marcus Nassar Palace is our case study with the HEAP project. Okay. This is the types, the traditional building types in Palestine. You can see that they usually started building one unit for the family, and when they expand, they usually build another one. It was 2 units or linear. Then we found something like a yard or the hosh. Also, we have the regular buildings, which was for usually public institute like schools or something like this. We can find like buildings with rewaq or gallery, what we call Liwan, which is the central space in the building. And we have the buildings with courtyards, and we have something combined. It was regular buildings and then added like another units around it. Here's like an example for a simple building with 2 units, linear units. You can see that it's not like on a plain platform or ground. You can see that there's, because it's a mountain area, you can see that one unit is above the other one. This one is a hosh or a courtyard. You can see here from a plan that you have like a linear elements, then you have a court for all the houses around it, and you can see how it was built differently with stairs in between it. I'll explain a little bit fastly about how they used to build these buildings, the heritage buildings. This is a type for the foundation. Usually they started digging until they reach like stones on the ground, and if they found like a hole in the ground or there is no stone, they usually put the arc to put like the force to the stone around it. Here's a section or 2 types of section for the walls they used. The one on the left is for like simple units because they used the stone, and above it they used like plastering only. And the one on the right, it's for the public buildings. They used to use tiles on the roof and also on the parapets. Here you can see a picture for the cross vault inside. When we remove the plastering, you can see how they used to build the cross vaults for the stone. That one is with they started plastering it for walls. Here's another section for the windows. It explains where the windows exist for the wall section, and you can see that it's not on the outer side, it's usually on the inside of the wall section. Now, for the passive design strategies in Palestine, the main tools and methods to analyze the passive systems is to calculate the outer climate area of the building with the existing, or to reach the comfort for the occupant inside the building. I will explain the main strategies, the passive strategies in Palestine. You can see that the passive, I will explain it a little bit for people. The passive systems is to use the natural systems available without any mechanical or electrical devices to gain the comfort inside the building. Like we can start with the natural ventilation. It depends on like four things: the wind, the location, the aerodynamic dynamic of the building, the surrounding of the building, the obstacles, the trees around it. I will explain more about this. This is Marcos Nassar, our case study. I will explain more about the cross ventilation here and the stack ventilation. Secondly, the thermal mass. Thermal mass in a heritage building is always there because the walls is like 1 meter thick or 80 at minimum. So you can see that because of the thickness of the wall and the material we used, you always have like a thermal mass. Thermal mass is we can explain it by the time the heat needs to come from the outside of the building to the inside and vice versa. Secondly, we can say about the reduction of thermal losses. Some of these were like were existed in the thermal in the heritage buildings, and some of them are not. Like the minimizing infiltration, it wasn't existing in the heritage building. Like you can see in this photo, you can see around the door how it's open. It's maybe 5 centimeters, like you have a hole, and but you can see that they created buffer zones in the building. Always we have something called Liwan, which has like the public space in the building with the stairs. So it's good for ventilation, the stack ventilation I mentioned before, and for like it will be a buffer zone because always the main doors are in this area. Also about the internal gains. Internal gains is what the heat produced inside of the building from people, from machinery existing inside. We can say about this that it has increased with the time because they didn't have like machinery before or less people, we can say, and the function of the building of course changed from time to time. Now we can talk about the passive heating. We have more than one. We can the direct solar gains. Direct solar gains is to use the heat from the sun rays, to let it, like in the winter, we can let it inside to heat the thermal masses, the floors, the walls, and at night it will be released to give more comfort inside the house. And by summer, because of the angle of the sun, it won't enter inside the house and it will give more comfort. And for the heat, we can do the night flush or the ventilation. I put the window section here with the wall to explain something that in the heritage building, because of the thickness of the wall, they like already achieved 50 to 60% of the shading elements, because the sun in summer can enter like for 1 meter inside the house only. So with a little help from us with the shading, we can achieve the maximum. And also about the indirect solar gains, that's the same as before, which you will heat an element from outside and then let the energy goes to the building. It's either like slabs on the roof or walls or windows, etc. About the passive cooling is also using the natural elements around us to achieve like cooling inside the house and to avoid overheating. I put these photos to show some of the shading they used in their architecture and how they can use like the planting around it. They use the balconies to achieve like to do the shading, to not let any sun inside of the building. About the shading here, we can explain more. The photos on the left shows a building with a courtyard and a gallery around it. Usually the sun doesn't go inside to the doors and windows and give them like shading. And the two photos on the right is about what we call mashrabiyya. Mashrabiyya is an extruded element outside of the wall. It's usually a window. They use it for two reasons. The first one is to not let the sun enter, and the second one to sit on it and see the views outside. Yeah. Also here, like the shading, you can see how the balconies with the planting they used at the entrances. You can see how the windows are extruded to the inside, so they will give shading from the elevation itself. Of course, the ventilation, the one I wanted to speak about before, you can see here, yes, you can see here the cross ventilation, which I was saying about the buffer zone. You can see with the stairs, the windows always, they use it from west to east, so they can gain the wind. And then you have the the stack ventilation, which goes above the stairs because it's open until they have windows outside. And there's the cross ventilation, but it was on the single floor roof. We have the radiant cooling or the night ventilation. They use it a lot in the heritage buildings, which is to let like the thermal mass, they let the heat go into the objects, and at night they open the windows and the doors to do the night flush. I don't have enough time. Okay. Lastly, we will say about the evaporative cooling, which they used it mainly in public buildings. You see when they have court or gallery, they used to put like a water element, like to do the heat sink. And this used to give like, to reduce the heat around it and to get like something. Lastly, before my colleague explained the active systems, I want to address something. Is that the passive building, or the heritage building, sorry, is closer to zero energy buildings than the modern buildings. So, but what's different and what we need to address is that the internal gains has been different before for the heritage buildings and now, and the function is different because they used to be like houses, now we use it as schools and etc. And the climate change, of course, what we used to be talking about for 2 days. So what I mean that is the active systems that we need to use in the buildings is only to cover what has been changed and not to use it for the whole building. Thank you, and I will let my colleague explain.
Active energy efficiency design strategies. Actually, a balanced interplay between the passive and active building elements is often the final goal of an efficient retrofit strategy. So passive passive systems are they transport and collect heat by non-mechanical means and operate in the immediate environment. In contrast, active systems import energy such as electricity to power the mechanical systems. Also, the passive systems depends on the building fabric and environmental natural processes, and it's mainly focused on saving energy. Active systems are also saving energy, but both technologies are affected by the environmental conditions. Both act differently when the sun is out or the wind is blowing or if it's cold outside. So energy improvements in historic dwellings should cater for the minimum intervention. So it must be there must be preservation of the building materials as much as possible. Reversibility, it should be the interventions. It should be reversible in the future whenever possible. It should be also the interventions compatible with the ancient building materials, with the new ones, and also respect for the material and figurative authenticity of the building. When you design, you should aim at or to prevent the energy leakage from buildings and the maximization of efficiency of heating and cooling system, and the incorporation of innovative technologies for the production of energy from renewable energy sources, which is a key point in reaching nearly zero energy consumption in buildings. I want to say that energy efficiency improvements could save you up to or more than 25% of the building consumption. However, with renewable energy systems, you could cover the rest of the 75% to reach nearly zero energy building. The main active strategies of heritage buildings in Palestine. The first one is thermal insulation. Exterior insulation is generally recommended as it consists the least expensive and technically least demanding solution. However, in case there is insufficient space for exterior insulation, interior insulation is advisable. energy efficient equipment, making smart choices when buying cooling and heating appliances, water heaters and everyday appliances is going to set you up for comfort and will lower the cost of your bills, of your electricity bills. And actually high energy efficiency, I don't want to too much time, but system efficiency, actually lighting is one of the important and large consuming electricity and usage in the buildings. So implementing smart controls of the technical systems can increase their overall performance, maybe replacement of the light bulbs and ancient or previous one with LED bulbs and lamps. It could save you money, it could save you electricity. Solar water heaters, solar water heating systems are used extensively in Palestine, and technicians are well experienced in installing such systems. A check performed after installation to ensure that there is no leakage in the water heating system and there is no water seepage in the roof where collectors are fixed on the roof. The last one is photovoltaic system. Actually, in Palestine, in 2012, we were encouraging people and convincing them to use and to install photovoltaic systems. We have launched the project called 1000 Home. It was for 1000 home for investors to install photovoltaic systems, and the price was based on feed-in tariff. It was good for investors. And now in 2022, some cities are more than 40 or 50% of their consumption are generated from renewable energy, and there are some homes that in some areas cannot install photovoltaic systems because of the inverters are full of the percentage that could be handled for renewable energy. So the photovoltaic system in the heritage buildings should be compatible with the building elements and these specifications. I don't know if the time is. That's it. So it's okay. Thank you for listening, and thank you for.